Hi, my name is Farine and I'm a developer.
And I'm Adrian, and I'm a designer. And today we're going to talk about high-performance animation. Before we get into that,
You know the drill.
yeah, more drinks.
Karma Cola.
We could use good karma.
And good karma is always a good thing.
Although I doubt it comes bottled.
Okay, here we go. Let's save a bit for our lovely camera lady.
I don't know if she'll like this. Just.
Very cinnamony.
Yeah. This tastes like the Red Bull raw, no, the Pepsi raw cola.
Good to know.
It's not bad. Not bad.
High performance animations.
Yeah. What can you tell me about that? Because this seems like a very technical topic and I'm not that well versed.
It is a somewhat technical topic. We were talking here about CSS transitions and CSS animations.
Okay, so we're not talking about SVG animations
No,
or
no,
anything
no,
of
no.
that sort.
No.
Okay.
And we want them high performance. That means we want to have 60 frames per second always, and we want them to be snappy and not delay anything. That means you have to do stuff on the graphics card.
Okay, seems reasonable, I guess.
Yeah, but it's a little bit more complicated. I went to the Fronteers Spring Conference here in Amsterdam, and Tobias Ahlin
Of Always Be Removing fame,
Yeah.
which we referenced earlier.
he talked about if you do animations, you can only use GPU accelerated properties.
Okay.
And that means in CSS, we can only do animations with opacity, filter, and transform, because these can be done on the GPU.
Okay, that sounds reasonable.
You don't think that's going to limit you?
I don't think it's going to cure everything, but I mean, look, half the battle is knowing. For me as a designer, if I make animations, it helps for me to know, well, if you make an animation using opacity or filter or the transform things in I call them things, pro tip, in CSS, they will be more performant, or they will render faster, yeah.
Yeah, the video from his talk is actually online, so dug a little bit deeper and see why is this faster. First thing you have to know is that your graphics card is extremely good at working with processing images. So
Bitmaps, basically.
Bitmaps, rasterized bitmaps. So when you can do an operation with that bitmap on your graphics card, on your GPU, it will be a lot faster than when your CPU has to calculate it and then draw it again.
Yeah, okay, and then goes back to the GPU, no?
Yeah, let's look a little bit into how your browser actually puts stuff on your screen. It's abstract and it may not be 100% complete, but what your browser does is it will lay out your screen with CSS, and then it will split it into different layers. But it's like layers of different things that have rendered on top of each other.
Okay, so it just stacks them, basically.
Yeah, it stacks them. And then it's going to paint those layers on the GPU into bitmaps. So it will put the font and it will render it, so it gets pixels.
So is this on the GPU or on the CPU?
No, this is on the CPU.
Okay.
This is what your browser does on the CPU. And then once it has painted such a layer, it's called a paint,
yeah.
It will upload that as a texture into your GPU. So then it's in the GPU memory. And what your GPU then does is composite these different layers into the final image that's going to be shown on screen.
Okay, so it uses them basically as textures on your screen.
So this is basically, okay, you do some layouts, split it into the DOM into layers, paint those layers into software bitmaps, upload them to the GPU as textures, and then composite these layers into a final image on the screen.
That you actually can see.
Okay. Yeah, that you actually can see. Now the expensive bit here is the layout and painting.
Your CPU has to do that?
Yeah, your
and
CPU
it's not
has
really
to do
good
it.
at that.
Well, it is.
It's not shit at it.
No, it's just an expensive operation.
Okay.
Because you have to transform. It has to transform the font into pixels. It has to make sure that the text has been, that's the layout bit, that will flow correctly, that the image will, the images will go in the right place and stuff like that. And then split that and upload it and paint it rasterize it, and upload it into the GPU.
And I'm assuming this is slower than your GPU because it is not optimized to do this.
I'm not an expert on how a CPU works,
Okay.
but once it's rasterized, your GPU can really do operations on that really fast. And that's why you can only use opacity, filter, and transform, because what your GPU does is, for instance, changing the opacity is for a layer is just changing the amount it shows of that layer.
It doesn't physically change what's in the picture. So
no, it doesn't have to look again at the font that's in there. The box didn't change. It doesn't have to reflow the text.
No, the image doesn't change. So, for instance,
no, exactly. It just draws the image on top of another layer in a different
But if you
combination.
Want to, for instance, change something from blue to red, that would require a repaint.
Yes, exactly, because your CPU has to draw the image again.
Yeah, because your CPU or your GPU can't actually draw images. It can't.
No, it gets instructions of what pixels to put on the screen, and it can do all kinds of transforms with those, but it doesn't do the painting itself. That's
so whatever's in there is in there. It can't change that, but it can, for instance, resize it. Or
it can resize, skew it, rotate it, and stuff like that.
Okay, as long as whatever content doesn't change.
Yeah, and that's why the transform properties can fully be done on the CPU. Yeah. And that's also why if you use scale, for instance, if transform scale property, you will get fuzzy images because it will just stretch the image.
Yeah, it will just
instead of repainting the text when you would just change your dimension of the box
exactly.
with width and height. Yeah. So you want to avoid, if you want to have high, and this is fine if you're laying out a page, but if you want to have a smooth animation with 60 frames per second, that means every operation has to be done within 16 milliseconds. So you want to avoid layout and painting within your animation. It's fine to do it at the start and at the end, but you want to avoid painting during the animation.
Because it has to fill in every frame.
So you want to have you want to be that to be done on GPU.
Okay, that's really interesting.
And that's
I've never really thought about it this way.
Yeah, that means you have to avoid animating any property that will change the bitmap, so that has to paint. That has to paint. So if you change the width, that means your text has to reflow, or it has to recalculate other stuff, and that has to be done on CPU. Upload it again to the GPU, and then paint, and then draw it on screen.
Yeah, exactly. So you basically have to do more steps to get things done. Okay, that's really interesting.
And that's why Tobias Ahlin says, okay, you have to animate objects and not properties. Yeah, that's how you work around these. You can actually fake a lot by using opacity, filter, and transform. You can fake quite a lot of animations.
I think so, yeah. I also use them already quite a bit for animation, simply because it's just the quickest way to get it done. So for many things, you can readily just use that. You probably use them already, so it's not going to be a big transition.
For instance, a classic case is where you have an expanding box.
Yep.
So you click on something and then it has to expand. That's a really expensive operation because it has to do the animation, but it also has to repaint everything below that box, because your box, once it goes slowly, it opens, and it has to move and then it has to do, that has to be done on the CPU, because it has to repaint every little step there. Yeah. And if you have a box that is overlaid and you would just scale that up, that's much easier, because the
surroundings don't change.
Only this one layer has to be
redrawn.
Well, you can. There's also a little bit of, if you can choose to only have that layer be painted and layouted. So that's what happens when you have it on a separate layer. But even better is to just have the scale animation fully on the GPU, and you're just using the transform. So that's a lot faster. And that's why you see a lot of choppy animation when you have expanding boxes that move content down.
Yeah, that move content down. That's always a
that's something you see quite often.
I like the effect of having stuff expand and move content out of the way. And every time my developers, or actually your developers, will tell me, "Nah, don't do that." So,
and in some situations it can probably be acceptable.
As anything on the web,
it depends.
Yeah. So we should call this show "It Depends," and then we'll just discuss everything that depends.
Yeah.
Okay. But this is for simple animations. I can totally get around with just opacity, filters, and transforms. I really like transforms.
Yeah. It's funny you mentioned the changing the color because and the way around that is by using pseudo elements.
Okay, that sounds
and then doing instead of, for instance, background color. And we have a demo about that. Shall we just look at that?
Yeah, let's have a look.
Okay, what I have here is two boxes. They're currently red, and two pseudo elements to blend in the background colors, and the other one I use just transform the background color.
Okay, so you on the awesome performance box.
Yeah, I have here the before and the after, and the after is now hidden. It's the blue color.
Yeah, opacity 0.
Yeah, and I just do. Where's the awesome? I will have a transform here, and on hover, I will show
the opacity
on. Yeah. So
okay, and you use that index to actually move the before behind
and
it.
And the actual result is this, and here as well.
Okay, so they basically look identical.
They do. We talked about layout and painting. So let's open the web inspector here and look at the timeline. And we're going to pay attention to the layout and rendering bit. I'm going to turn this on, and I'm going to hover on this one. And you see it paints twice, and when I go up, it paints twice again. Okay. When I do that on the sucky performance bit, it will do a lot of painting, and it will do a lot of painting.
Okay, interesting.
So as you can see, this is what we talked about. It has to, for every step in the animation, it has to do on the CPU. It has to recalculate the new color and then upload it to the GPU and then show it.
Okay. And it has to do it on the other one. It has to do it twice.
No, it starts with the beginning and it uploads it, and then it does the opacity layers. It will do that on the GPU, and in the end, it has the final state, and it will redraw that. Okay. So it's just two draws, and in a simple example like this, it doesn't really, the frame rate doesn't really drop that much. But if you have a more complex animation, it will matter. A more complex interface or elements, it will matter a lot.
Okay. So this is really cool because as a designer, I wouldn't have come up with this solution. I wouldn't have thought, you know what, I'm going to do a color transition using a pseudo element.
Befores and afters. Yeah. No, I know.
Mostly because I like my pseudo elements for other things.
That is one of the issues you may run into, and that's the thing that, and I know markup purists will hate me for that, but sometimes you'd have to add extra elements just to have a better performant animation.
Okay. Well, I tend to, as a designer, I'm not really.
You don't really care that much.
Well, I should care about it, but sometimes I do weigh the visual gain, as it were, or the user experience gain against how much elements I have to write to get something done. So I'm not that purist about it. I
get that. And it's also a trade-off for what is practical. And I mean, a div, semantically, a div or a span doesn't really mean anything. So except you get a little bit of more ugly code. In some situations, it just might be fine.
Yeah. Then again, it also might snowball on you and stack up and be illegible after a while. So that does also happen. But I think there is a real concern with practicality in this, especially for the more complex animations.
Yes. And sometimes you'd have to go with something that looks less like the intended effect. Okay. So you have to fake some of this.
Sub-awesome.
Sub-awesome, yeah. For instance, I actually made another demo which will, instead of animating the box shadow, it will also use a pseudo that scales. So you want to have a look at that?
Yeah, let's have a look. So this is the next demo, yeah?
Yeah, I've got two boxes, and they do this. If I mouse over, they will
look more or less the same.
They look more or less the same, yeah. So let's look a little bit at the code here. I have a win and a lose, and there's a bad performing one. There's a good performing, two diffs, and this is some boilerplate code to just place them and make sure that the loser goes down at the bottom. And this one has a box shadow, two box shadows actually. It has a white border. This is in the standard. In the default state, it's just non-existent, but we need that to animate it. And then it
so
has
it's just value 0.
Yeah, it has a and it has a value. It has a fuzzy box shadow that will grow. And what we do is we actually make the spread values grow so it will look like this.
Okay, so you're basically faking a border.
We're faking a border, and if I'm going to change the color here so you can see the effect. So what happens is this.
Okay, so it basically just adds the spread of the first box shadow.
Yeah, and the other box shadow is a non-fuzzy one. So, but if I make that white, it will just look like the box grows.
It grows. Okay, that's cool. That's probably how I would do it.
Yeah. So then we have the other situation, and here we use a before element, and that's absolutely positioned to be exactly the same size as its parent.
Okay, so you just put everything to 0.
Yeah,
bottom left,
yeah,
right,
top, bottom, left, right, and we transition a transform here, and what we do is it will. I put the box shadow here in a separate selector so you can see this is just this box shadow. Yeah. So and on the hover it will just scale, and that's what it does here.
Okay, and that's a GPU accelerate because
it's a GPU. Yeah. Okay. Yeah. Let's have a look at what the paints and layouts do here. So again, we have these two boxes, and I'm going to record this. And when I do this one, it will just have two paints, one's the beginning and the end. And if I do this one, it will paint a lot. Yeah. And it stops painting here again. So that's, again, here you see it has to calculate every state and upload it to the GPU.
That's really cool. And just because it uses one pseudo element is also not that obtrusive for me. So it's not like, I still have the after if should I need something in a pseudo element.
Yeah.
I like my pseudo elements, I'm sorry. But that's really cool. And it's also interesting to see it visualized that it actually makes a real difference. And I mean, these are isolated, simple examples.
Exactly, yeah.
But I can imagine this adding up quite a lot. I mean, if you add more and more
properties and you have a background image and so that matters a lot.
That matters a lot, yeah. And especially on less powerful devices, I can definitely see
absolutely.
Yeah. So on low-end smartphones, for instance, I can.
Yeah. You may be able to do a lot of animations. You may be able to approximate a lot of animations by just winging it. But there may be some animations that just are really hard to do.
Yeah, that are impossible to do using this technique.
Yeah.
But I do think it's worth thinking about that when we make animations,
absolutely.
that we at least consider, and perhaps even if it's already an animation-heavy site, that we do look at these things and try to make an informed decision on what is a good use of our processing power.
Yeah.
So to make, I mean, sometimes that will mean we have to compromise, so we can't have everything that we want. But you know, that's the web for you, I guess.
Yeah.
And I mean, for one, I would rather have snappy, high-performing animations than shitty ones, basically. So and even if they have to be less or not as pretty, that will be fine by me. Yeah. I'm good with that. Cool. So I think that wraps it up. Thanks for the examples. Really nice. So thank you for liking, commenting, and subscribing. And we'd like to thank our sponsors, Asphalt Photo and Repaint, for making this episode possible. And we'll see you in the next one.